Hello everyone, welcome to ESE Online. In today's video, we will discuss about what are the important topics, or I can say it is not possible to cover the entire engineering mechanics guys in this 1 hour of video. So I have chosen two topics basically. From the topic, there is a high chance of getting the question guys. ఏమైంది రావట్లేదా
అది వస్తుంది సార్ మీరు రావటం లేదు అది సార్ ఏమవుతుంది సార్
అని చేయలేదా ఆఫ్ చేసావా ఆ లైవ్ పర్లేదు ఏం కాదు కొంచెం లేట్ అయినా పర్వాలేదు ఏం కాదు కూల్గా కూర్చో
ఓకే సార్ ఇది వీడియో రావడం లేదు, అది ఒక ఇమేజ్ మాత్రమే పాస్ అవుతుంది. ప్లే చేశాను ఆల్రెడీ. ఎక్కడ ప్లే చేయాలి? ఓకే
ఇది ఓన్లీ ఇమేజ్ వస్తుందా?
అవును.
మైక్ ఆఫ్ చేయవా? మైక్ ఆన్లో. సార్ ఇప్పుడు బోర్డు దగ్గర ఉందా?
బోర్డు దగ్గర ఉందా? మైక్ ఆఫ్ అయిపోయింది. ఒక్క నిమిషం.
Yes, I'm sorry guys, sorry for the interruption, a small technical problem. Guys, we'll start the session with discussing two important topics guys. First one is Lamis theorem, second one is wedge friction guys. Are getting an answer? We're going to discuss with the Lamis theorem and wedge friction. Now coming to first one. Guys, Lamis theorem. Basically, where we use the Lamis theorem guys. Suppose on any object, if there are only three concurrent forces are acting, and these three concurrent forces are keeping the object in equilibrium. What is mean by equilibrium guys? Equilibrium means the body is in the state of rest. If three forces are keeping the object in equilibrium, then we can comfortably use the Lamis theorem to find out the unknowns guys. But what is this Lamis theorem? How can you find out the unknowns? This is what we are going to discuss now. Now observe carefully sir. What is the Lamis theorem? It states that if, see this is the condition guys, three concurrent forces are keeping the object in equilibrium. There should be only three forces, and these three forces are keeping the object in equilibrium. Then each force is proportional to the sine of the angle between other two forces, and the constant of proportionality is same guys. What exactly it means? Listen carefully. Assume there are how many forces are there guys? Three concurrent forces. Assume this is the P, this is the Q, and this is the R, and this is the alpha, this is the beta, and this is the gamma guys. Then according to this theorem guys, P by sine of angle between other two forces, guys. P by sine alpha must be equal to Q by sine beta must be equal to R by sine gamma, guys. But here only one thing you have to keep in your mind is, guys, whenever you are finding alpha, beta, gamma, guys, you have to listen carefully, sir. You have to take all these forces should be outward to the point, because while solving the problem, sometimes what happens is, guys, some forces are inward, some forces are outward, then you get confusion while finding alpha, beta, gamma, guys. Only thing remember, alpha, beta, gamma are measured. Alpha, beta, gamma are measured when all the forces are acting away from the point of concurrency. This is called point of concurrency. Please take this point, guys. Are measured only if all the forces are away from the point of concurrency, guys. Now we'll solve one question, guys. You get the idea. Question number 1. Find alpha, beta, gamma. Find alpha, beta, gamma. Here what happens, guys? P is inward, QV is outward, again R is inward, guys. Again R is inward, but my question is to find out alpha equal to how much, beta equal to how much, gamma equal to how much. I am giving 1 minute of time. Please try to answer it, guys. Please try to answer it, alpha, beta, gamma, guys. I am watching your comments. Please try to find out, guys. Please try to give the answers, guys. Try to give alpha, beta, gamma. Yes, sir, Ravi, I'm going to give you only few concepts, someone that's already discussed. Let us see who will give me the answer, guys. Okay, first, I will tell you guys, listen carefully. If I take the first point of concurrency, first what is there? QV is there, guys, Q, which is making an angle of 20 degrees with respect to horizontal. Next I am having R, but R is coming inward, guys, R is coming inward. What to do, guys? As it is coming inward, as you know, transmissibility of force, guys. In that, what I should do, I can transfer the force along its line of action, but effect on the object will be same. Yes or no? Same way, I just transfer the R to the outward like this. I'm sorry, sir. R outward like this. This is R ka story is over. Next, P ka story, guys. I can transfer the P along its line of action. Same P I can transfer it, guys. Same P I can transfer. But this P, how much angle it is making with respect to horizontal? 30 degrees, guys. Now observe carefully, sir. Now I want to find out alpha equal to how much, beta equal to how much, gamma equal to how much, guys. So what I can say is, observe carefully, sir. Observe carefully, sir. Listen carefully, guys. First, I will take it. First, P is there. Lamis Format, amma. This is the QV is there. This is the R is there, guys. R is there. Okay. Now tell me, sir. Angle between P and Q, how much? 50. Angle between R and Q, how much, guys? This is 20. This should be 70, guys. This is 70. Then angle between R and P, how much, amma? As we discussed, guys, total angles alpha plus beta plus gamma equal to 360 degrees, amma. Then I know already 70 and 50 I know. Gamma, this value equal how much I can able to find out, guys? 360 minus 50. How much? 310. 310 minus 70. How much, guys? 240 I am going to get. This is the value, sir. Now observe carefully, sir. What is mean by alpha, beta, gamma? Here, what is mean by alpha, beta, gamma, guys? Alpha equal to 70 because P ka opposite is 70. Q ka, this is the beta. You should get the same value, guys. Gamma should be 70 comma 240 comma 50. If the order is changed, it is wrong answer, guys. Even though you got the same values, if the order is changed, it is a wrong answer. Let us see who has given this answer, guys. Abhishek, small mistake, Abhishek. Think about it. Do you understand, guys, everyone? Yes. 70, 240 and 50. This is the correct answer, guys. Now, I will go to next question, guys. At least. Now, please go through this one. Please go through this one and try to give the answer, guys. Please go through this one, try to give the answer. Everyone. Try. Again, here also same logic. I given PQR. Find out alpha, comma, beta, comma, gamma, guys. Definitely, alpha should be P ka opposite. Beta should be Q ka opposite. Gamma should be R ka opposite, guys. It should be the same format. Let us see who will give me this answer, guys, this time. I'm expecting answer from you guys. Veera, Ramu, Abhishek. Please try. Yes. Look at here, guys, same way. I take this point of concurrency, guys. I take this point of concurrency first. Take this point of concurrency. Now represent. See, first only R is outward. I know that. How much angle R is making with respect to horizontal, guys? 80. I know that. Next, P. I can send it outward, guys. P. How much it is making with respect to vertical, guys? 10 degrees. Next, Q. How much is the Q is making with respect to horizontal, guys? 20 degrees. Now, yes. Now everything is ready. Now let me come to the Lamis format, Amma. Let me come to the Lamis format, guys. Now look at here carefully, sir. What is this Lamis format? This is P, this is the Q, this is the R. Tell me, guys, angle between P and Q, how much, Amma? 10 plus 90, 110, 110 plus 20, guys, sorry. 10 plus 90, 100, 100 plus 20, how much, guys? 120, Amma. 120, I know it, guys. Next, this is 80. This should be how much, Amma? 90. This should be 80 degrees, guys. This is also 80 degrees. This should be how much, guys? 160 degrees. And remaining thing, how much, Amma? Very simple. 360 minus 160. 360 minus 160, guys. It is a 200. 200 minus 120, it is the 80, guys. Now, let me explain you, guys. Now, alpha equal to how much, guys? This is the alpha. You should get the same things. This is the beta. This is the gamma, guys. Which means that sequence should be 80, 160, 20. 80, 160, 20. Who has given the same sequence, guys? Very good, Beam. Your answer is correct. Remaining students, Mugilan. Yes, very good, Abhishek. Hope everyone got the clarity, guys. Good, good. Even if it is wrong, don't worry, guys. We come here to learn itself. No need to worry about it, guys. Okay, this is the one. Next, this is the actual question, Amma. Please go through this question. Please go through this question, guys. 1 second. Yes. Please go through this question, Amma. At least this question you try and you give me this answer, guys. The actual question. These kind of questions you will get in the exam. Please. I just practiced alpha, beta, gamma. This angle should be perfect, guys. This angle should be perfect, Amma. Please try. Yes, very good. Few students has given the answer. Let us check it, guys. Let us check it, my dear students. Let us check it, guys. Let us check it. Now, I am drawing a BD of point A. A BD of point A. This should be P. Yes or no? This should be what? F of AC. This should be what? F of AB. Do you agree or not, sir? Now I know that if this is 40, this should be 40, Amma. This should be 40. So angle between these two must be 40. Listen carefully, sir. 40. If this is 40, this is 70, this angle must be how much, guys? 70. If this is 70 is 40, this should be how much, guys? 30 degrees. So angle between these two will be 30 degrees itself. But what is the Lamis format here? What is the Lamis format here, guys? Very simple, Anna. So listen carefully. Lamis format, Amma. This is the P. P ka this side. How much, guys? F of AC. This is F of AB, guys. P2, this one, angle how much? 40, 30, guys. Remaining how much, Amma? 40 plus 30, 70. This should be how much, guys? 290. This should be how much, guys? 290, Amma. Now, answer should be what, first of all? P by opposite angle, guys. P by sine 30. P by sine 30. Next. Then tell me, guys, F of AB or P of AB, whatever it may be, guys. F of AB by opposite, guys, sine 40. Next, F of AC by sine 290, guys. F of AC by sine 290, guys. Now observe carefully. Which one is correct answer, guys? Which one? P by sine 30. P by sine 30 is there in the, yes, option B, guys. P by sine 30, F of AC by sine 290 and P of AB by sine 40. The answer is option B itself. Very good, very good, very good, Mugilan. Very good, nursing. Very good. It's very difficult to pronounce it. Psychedelic. Delic. Very good, very good, Delic. Ratnateja, very good. Very good, Amma. Very good, very good, very good. Petchapan, very difficult to pronounce it, such kind of names. Very good, guys. Now, coming to this is the basics about the Lamis theorem, Amma. They are going to give you, because this Lamis theorem concept is used in multiple other concepts, guys. Like in equilibrium questions, guys, they used to use the Lamis theorem. And especially in the wedge friction, they used to use it, guys. And in multiple friction problems also, we used to use the Lamis theorem, guys. In trusses, we use the Lamis theorem. So it is having a broad application, Amma. but only thing students used to confuse is about the angles. That's why we have practiced 1, 2, 3 questions so that you can clear this concept, guys. Okay, let's see. Wedge friction. First of all, you'll understand what is mean by wedge. What is mean by wedge, guys? See, wedge is a simple machine tool of triangular or trapezoidal cross section made of wood, metal, plastic or stone. You might have seen, guys, this is a kind of wedge, guys. But what is the main purpose? You have seen tire wedges. Are you getting it, sir? Tire wedges are simple metal, like simple wooden wedges, guys. These things you have seen, guys. What is the main application of the wedge? Where you have seen these wedges, guys? Tire wedges are very frequent, guys. At the same time, if you go to any industry, basically wedges are used to rise or lift heavy loads. It is used to rise or lift very heavy loads by applying very significantly less horizontal force. If you observe carefully, sir, I'm having, this is the wedge. This is having wedge. This is the load W. This is the, you apply the force F, guys. You apply the force F, guys. So when you try to move this wedge, this block will try to move it upward direction. When you try to move the wedge, block moves upward direction, guys. Are you getting an answer, everyone? So it's one of the advantage, guys, by applying less horizontal force. And at the same time, it is used to split the solid objects like wood into 2 separate pieces, guys. The wedge-shaped tools, if you go to any cutting tools, the cutting tools are used to split the objects very easily, sir. There also the concept is wedge itself, guys. You can see the, yes, triangular shaped tool, guys, which is used to pierce it very easily, sir. Come to our day-to-day applications, we use this concept very frequently in multiple places, guys. But where it is, think about it, my dear students. Think about it, guys. So like if you take our knife, chisels and axes are a pretty good example of a wedge, guys. If we go to day-to-day examples of our wedge, knives, forks, scissors, this we discussed, guys, everywhere. Because if you see, cut the cross section, guys, having a slant face, having a like smooth face, guys, over there, having a triangular shape or trapezoidal shape, you used to find out whether you take a knife or scissors or anything, guys. Next, if you take a peeler, a typical example of peeler, guys, having the concept of wedges itself. Next, shovels, you can see, guys, the shovels, push pins, typical example. And stoppers, we use it, guys. Stoppers, those are typical examples. Now I'm asking one question, guys. Tell me the wedges, what is there in our body, guys? With that, we used to cut the objects very easily, sir. In our body also, we are having so many wedges, guys. What are those? Think about it. Think. In our body, we are having so many wedges. With that, we do something work. What is that? Very good nursing. Excellent, amma. Our teeth is the best example, guys. Why? Because, sir, observe carefully, sir. Especially front teeth are rare teeth, guys. Front teeth, amma. Because suppose apple is given to you or chicken 65 is given to you, guys. You want to pierce it. How do you pierce it, guys? You try to pierce it. The front teeth are rare teeth, guys. Front teeth. The main purpose of the front teeth is to bite it. Pierce it. It can pierce very easily. If you can touch your tongue, you can see, guys, cross section. You see the cross section of your teeth is like this itself. It can very sharp. It can pierce it very easily, sir. You remember, guys, during our childhood days, what is the best weapon we are having when your friend is like teasing you, when your friend is harassing you, guys? Best weapon. I don't know about you guys, but for me, the best weapon is there, guys. If some of my friend, he's like harassing me or he's teasing me and all, only weapon is I used to bite him. and in the school days, guys, okay? Don't take it wrong. This is the best weapon, guys, we used to have. Because especially rare teeth is used to chew the objects, guys. Front teeth used to bite something, pierce it something. Again, the concept is a wedge concept we used to use, guys. Are you getting an answer, everyone? Yes, sir. Now coming to, guys, observe carefully. Analysis of wedge. This is what is required from exam point of view, guys. How do you analyze the wedge? What exactly we do, guys? See, observe carefully. The first thing is, guys, as already discussed, this is the wedge, Amma. This is the wedge. In the analysis of the wedge, we ignore the weight of the wedge, guys. We ignore the weight of the wedge. Generally, sir, wedge weight is very, very, very less. Like if you take a tire wedge, tire wedge weight is very, very small, guys. Are you getting an answer, everyone? So wedge weight is generally ignored compared to load it is lifting, guys. But if they given in the question, we have to consider, guys. But generally they won't give in the question. If they haven't given means you have to ignore it, guys. Next, mu equal to coefficient of friction between all contacting surfaces. If you take this example, guys, how many surfaces are in contact, guys? Here, observe carefully. Assume this is the surface 1. This is the surface 2. This is the surface 3. We are having 3 surfaces in contact, guys. Surface 1, surface 2, surface 3, 3 surfaces in contact. Every surface is having what exactly, sir? Having a coefficient of friction. Next, alpha is the wedge angle, guys. What is this wedge angle? This is the wedge angle, Amma. This is the wedge angle alpha. This is the wedge angle alpha, guys. Next, they used to ask the question, basically it's the same question they used to ask, guys. What is the force P required? What is the force P required to lift the block of weight W? To lift the block of weight W. Iska weight is W. What is the force P required? What is the force P required to lift the block of weight W, sir? But before starting, I would like to ask you, sir, alpha, wedge angle is there, na, sir? You want to have more wedge angle to raise the load easily, or you want to have less wedge angle, Amma? Think about it, guys. Significance of alpha. You want less alpha or more alpha? Think about it. Think about it, guys. You want more alpha or less alpha, guys? Think about it properly. Everyone, let us see. Very good, Veera. Very good, Veera. Very good, guys. So many students given the answer, guys. Very good. See, listen carefully, sir. Observe. Or I can able to say, I am having an axe with more alpha, alpha 1, with less alpha, alpha 2, guys. Which one can pierce into the wooden log very easily, sir? If it is as sharp as possible, alpha should be as small as possible, then it can pierce it very easily, guys. Do you agree with this or not, sir? Yes, sir. Here answer is what, sir? Alpha 2. So it should be as small as possible, sir. It should be, alpha should be as small as possible to lift the object or to cut the object very easy, guys. To lift objects very easily. Anyway, that is out of scope, guys. Now my task is to find out force P required. P equal to how much to lift the block of weight W. Now listen carefully, sir. Now every wedge problem is similar, guys. We used to draw the FBD of the wedge and block, Amma. First, I'm taking the wedge separately, guys. Tell me the FBD of this wedge, guys. FBD of this wedge. First, observe carefully, sir. You apply a force F, guys. This is the W, guys. Listen carefully, sir. Force F or force P, whatever it may be, sir. Assume you are applying the force P. This is the P, guys. Next, this is the angle is how much? Wedge angle alpha. Wedge angle alpha, guys. Now observe carefully, sir. Is there any weight of the wedge is there? No. Amma, I'm telling one more time. FBD is all about, just 4 points, please write down, guys. FBD is all about representation representation of the weight, representation of external forces, representation of the supports, representation of the surroundings on a selected body. Here I am drawing on the wedge. So I should represent weight. Weight is not there. Next, representation of what? External force. Only P is there. Now, supports, guys. If I take supports, means here my intention is a hinge support, roller support, and fixed support. Nothing is there here, guys. Next, surroundings. Yes. Iska surrounding is what? Bottom and top. Bottom and top. These two are the surroundings for me, sir. But on the surroundings, how it will be, guys? As mu is the coefficient of friction between all contacting surfaces, guys. Between all contacting surfaces, I can say, listen carefully, sir. First, observe carefully, sir. Weight is not there. The ground will give you normal reaction N1 and upper part will give you normal reaction how much, guys? N2. N2. Can you help me how much angle it will make with respect to vertical, guys? This angle equal to how much, guys? Alpha or not, sir? If you want, you can verify, sir. Because simple logic, sir. Please verify. Alpha, this should be 90 minus alpha, this should be alpha, guys. Are you getting it, sir? It should be alpha. Next, normal reaction is done. As there is a coefficient of friction is given, there should be friction force exist. How is direction of friction force? When you try to apply the force, direction of friction force should be opposite. How much, mu times of N1. Here, guys, again, mu times of N2. Do you agree with this or not, sir? Because when you try to move, friction will try to opposite, guys. This is a typical FBD of wedge. Or one more thing I would like to say. Normal forces are, listen carefully, sir, because N1 and N2 are normal forces are perpendicular to the contacting surfaces. These are perpendicular to the contacting surfaces. Friction force are along the contacting surfaces opposite to the motion. It should be always along the contacting surface opposite to the motion. These things you know it, guys. Now I am drawing FBD of the block. First, representation of the weight. Here no external force is there, guys. And the surroundings. Tell me, sir, this is giving reaction downward. This will give the reaction upward, same N2. This angle equal to how much, guys? Same alpha. Now, this is giving friction upward. This is the friction downward. Action reaction, guys. How much? Mu times of N2, Nana. Mu times of N2. Now, observe carefully, sir. Here, this another surface 3 will be there. Reaction N3. Now, direction of friction force is how it is, guys. Direction of friction force, how it is, guys. Think about it. When you try to push it, the block will be moving upward. So direction of friction force should be downward, guys. Should be downward. How much? Mu times of N3, especially in the friction topic, whenever you are representing N and mu N, try to represent like this, guys, so that both the arrows are coming together. But again, the question is why. We will discuss, guys. Listen carefully. Why we will discuss. For time's sake, don't represent N here, mu N here, like that. Don't represent, guys. Why I will tell you now. Observe carefully, sir. Observe carefully, my dear students. Observe carefully, guys. Here, to find out P and W, guys. Here, how many forces are there in the wedge, guys? 1, 2, 3, 4, 5. Here again, how much, guys? 1, 2, 3, 4, 5. If you try to solve this problem using left equal to right, upward equal downward, clockwise equal to anti-clockwise, it takes a lot of time. It kills your time, and more than 10 minutes it will take to get the answer, guys. But we can use Lamis theorem here. But you can ask the question, sir, just now we discussed that Lamis theorem is applicable only when 3 forces are acting. But why you can able to use the Lamis theorem? With the help of angular friction topic, guys. You might be knowing, sir, whenever one normal reaction is there, whenever one normal reaction and coefficient of friction is there, I can replace these two with a single resultant or But how much this R is making, guys? Angle theta with respect to normal reaction. But this theta formula equal to how much, guys? Anyone? Theta equal to tan inverse of mu. Theta equal to how much, guys? Tan inverse of mu. N and mu. Theta will give you, guys. Mu is the coefficient of friction between the contacting surfaces. So R is the resultant of this friction force as well as normal reaction. Theta is angle made by resultant with respect to normal reaction. Only with respect to normal reaction, guys. So I can replace these two with a single resultant. Same way. But how can you get theta? With the help of tan inverse of mu, guys. Now observe carefully, sir. Now I want to represent. This is the P. How is the R1, guys? Tell me, sir. R1 should be opposite. This is the R1. How much angle it is making? Theta. Clear, everyone? Next. R2 should be between these two. Because why I told you to keep it both are together? Because it's easy for me to analyze and represent a resultant, guys, here. This is how much, guys? R2. How much angle it is making, guys, here? It is making angle of theta. Not with respect to vertical, with respect to normal reaction, guys. Now tell me, how much is the R2 is making with respect to vertical, guys? Alpha plus theta. This is the point, if you remember, guys. Always on the inclined surface, it makes an angle alpha plus theta. Now, here again, tell me, sir. Now it become P, R1, R2, sir. I can simply use the Lamis theorem over there. Now again, here, tell me, sir. Same action reaction. R2, how much angle, guys? Theta. Are you getting an answer, everyone? Now again, R3. How much angle am I again here? Theta with respect to normal reaction, guys. Now, let's see how can I use the Lamis format. Same thing is there, Lamis format, guys. First, I will take for the wedge. Guys. Listen carefully. If you take for the wedge, guys, wedge, first P is there. I'm representing first. P is acting this direction. Next, R1 is acting, sir. R1 is acting. How it is acting, sir? R1 is acting. How much angle, guys? Theta with respect to normal. Theta with respect to normal. Next, R2 is making, just remember, guys, R2 is making how much angle, guys? R2 is making how much angle with respect to vertical, amma? Alpha plus theta. Just remember this one. R2 is making how much, guys? Alpha plus theta. Now I can find it very easily, sir. This is about for the wedge. Lamis format for the wedge, guys. Now observe carefully, sir. What is the Lamis format for the block, guys? First, weight W will be there. I will take one point of concurrence, guys. Weight W will be there. Next, observe carefully, sir. R3 will be downward. Because I should represent R3 should be downward. How much angle it is making with respect to this one, guys? Anyone? With respect to this one, theta. It makes an angle theta, guys. Theta. Next, please observe carefully, sir. R2 will be upward. How much this R2 is making with respect to vertical, guys? Anyone? Alpha plus theta. Alpha plus theta, guys. Are you getting an answer, everyone? So this is the Lamis format. But in this Lamis format, I want the relationship between what exactly, sir? Relation between W versus P. So what is the connecting link between W and P? What is the connecting link between W and P, guys? Only R2. So R1 is my useless force. R3 is my useless force. You can avoid the useless forces if you do with the help of what exactly? Lamis format, guys. Do you understand or not, sir? Yes. You please try. This is the format, guys. Now we'll solve one question, guys. You get the clarity, guys. Now you solve one question, you get the clarity, sir. Listen carefully, sir. I hope everyone is following, Amma. Now, please go through this one. A block of weight 1500 newtons. It is having a weight of 1500 newtons. Overlying a 10-degree wedge. So it is having a wedge of 10 degrees as clearly mentioned, Amma. alpha equal to 10 degrees. And the leaning against a vertical wall is to be raised by applying a horizontal force. He's applying a horizontal force P. Same problem, guys. Assuming that coefficient of friction between all contacting four surfaces mu equal to how much, guys? Anyone has given? Mu equal to 0.3. When mu equal to 0.3, can anyone help me, sir? Angle of friction, theta equal to how much, guys? Tan inverse of 0.3. Tan inverse of 0.3 means how much, am I anyone? Tan inverse of 0.3 means, please try to give me the answer, guys. Yes, it is a 16.7. Am I correct? Please verify, guys. Please verify. Yes. Is it coming same, sir? Please verify. 16.7. Very good, guys, sir. It's coming 16.7. Coming 16.7, guys. Coming 16.7. Now I got this one. Question is asking is, determine the minimum horizontal force required to raise the block. But what is the block weight, guys? 1500. Now listen, how we have to solve? Don't represent n, mu n and everything, sir. Directly represent a resultant, guys. So listen carefully, sir. Directly represent this one. Listen carefully, sir. First, I have taken a, 1 second, Amma. Yes. Directly I have taken a block, guys. I have taken a wedge, guys. On the wedge, what is acting, guys? Wedge, I want to find out P. Now directly I can take it R1, bottom will give the reaction R1. So why you are taking this direction? Because when the force P is acting here, this will try to resist, guys. R1, how much angle it is making with respect to vertical, guys? Anyone tell me, sir? With respect to vertical, how much, guys? 16.7 degrees. Next, R2, as just now I told you, sir, whenever inclined surface is there, which makes an angle, how much, guys? Alpha plus theta. 26.7 degrees, 26.7 degrees, guys. Now, if you go to the block, weight how much am I here given? Weight equal to 1500 he has given, guys. Weight equal to 1500. Next, same R2 will be opposite here. How much is this R2, guys, with respect to vertical? 26.7. Next, R3, how much am I? R3, how much is making with respect to horizontal, guys? Here R3 equal to how much, guys? Anyone? Because normal reaction will be here itself, 16.7 itself, guys. 16.7. Now observe carefully, sir. Now observe carefully, my dear students. Observe carefully. Now, listen, everything is fine. Now Lamis format. This is the P. This is the R1. R1, guys. This is the R2. R2. R1 is making how much angle, guys? 16.7 degrees. And R2 is making how much, guys? 26.7 degrees, guys. 26.7 degrees. So for me, connecting is R2. I just need to find out R2, guys. How use the Lamis format? P by sine of, tell me, sir, P by sine of this angle, how much am I? Opposite angle, guys. 180 minus 16.7 minus 26.7 must be equal to R2 by sine of how much, guys? 90 plus 16.7, guys. It is a 106.7. 106.7. Here from this R2 I will get, guys. Again from here, guys, observe carefully, sir. Lamis format. 1500 R2. How much angle it is making with respect to vertical, guys? 26.7. Next, R3. How much angle it is making with respect to horizontal, guys? 16.7 itself. Now, R3 is useless for me, sir. I want to find R2. How can I find R2, sir? Very simple. R2 by sine, tell me, sir, opposite angle, how much am I? 90 minus 16.7 must be equal to 1500 by sine, how much sir? 90 plus 26.7, 90 plus 26.7 plus 16.7. From this you get the value of R2. You get the value of R2. Put this R2 here, amma. Put this R2 here, you get the value of P. Anyone? Please verify, guys. Please verify, guys. Let us see who will give me this answer, guys. Please verify. See how simple it is, guys, if you can use Lamis theorem. Try to solve the same problem with the help of resolving the forces, guys. It takes a lot of time, amma. Please try. Who will give me this answer, guys? I'm giving 1 minute of time. Please try, guys. Let us see. Guys, try. Simple calculation, guys. Very good, sir. Very good. 1418. I think it seems to be promising, guys. Answer 1418, guys. P equal to 1418 newtons, guys. I think, are you getting same thing, sir? X. Very good, sir. So 1418 seems to be correct, guys. 1418 seems to be correct, guys. Now observe carefully, sir. Now we'll end up this session with solving the question given recently in the GATE exam, sir. GATE 2021, they given this question, guys. 21, they given this question. We'll check it, guys. What the question they given is, please go through the content, everything. I just briefly explain what it is, guys. He's applying the same P, he's applying the Q, guys. Q. Here, only this surface is having, listen carefully, sir. Only this surface is having a friction, amma. Remaining two surfaces, surface 1 and surface 3 is a frictionless surface, guys. Surface 1 and surface 3 is a frictionless surface. Angle of friction he has given, amma. How much has given, guys? Angle of friction? Angle of friction, sir. Wedge angle. Wedge angle, how much has given, amma? Wedge angle is given as 30 degrees. Wedge angle is given as 30 degrees. Next, theta. Theta equal to how much, guys? Only second surface is having, guys. Tan inverse of 0.2 because coefficient of friction is given 0.2, guys. How much this values are, anyone? Please calculate. Tan inverse of 0.2 means? Tan inverse of 0.2, how much, guys? Think about it. Please try, guys. 11 point something you get or something's 10 points. Please verify. Give the answer quickly. Yes, 11.3. Very good, guys. 11.3. Going to get 11.3, guys. I'm going to get 11.3. Then question is asking is, guys, if you see the question is asking is, what is the value of P as given? P as given in terms of some constant into Q, guys. P is equal to C into Q, then what is the value of C equal to how much? If you can having little common sense, I can directly give the answer. 2 is not possible, amma, because definitely my effort, P is the effort, and effort should be definitely less than the applied load, guys. 2 is not possible. 0.5, 0.6 are not realistic, sir. Why? Because my angle, wedge angle is very, very large, guys. So these are not realistic, sir. Answer should be 0.9. We will verify, guys. We will verify. See, is asking P equal to C into Q. P equal to C into Q, this C value equal to how much? First, I am drawing FBD of the wedge, guys. Listen carefully, sir. I am drawing FBD of the wedge. Everyone listen carefully, sir. Everyone listen carefully, guys. FBD of the wedge. Now, I am applying the force P. Applying the force P. Bottom reaction will be only R1 upward direction, guys. Why only vertical I have taken, why not inclined, amma? Because bottom doesn't have a friction. Bottom doesn't have a friction, only normal reaction exists, guys. But this inclined surface having a friction, how much, guys, anyone? R2. If you're having a little practice, I can directly write down, guys, here. How much angle it is making, guys? Alpha plus theta. Alpha plus theta, guys. Because always inclined surface reaction will be having an angle of alpha plus theta. Next. Now coming to the wedge. Wedge, guys. So coming to the block. If you take a block, my dear students, same logic applies here again. First, Q is acting downward. Next, again, R2 will be acting upward, guys. R2 will be acting upward. How much angle it is making with respect to vertical? Same alpha plus theta. Next here, only one reaction R3, guys. Why R3, my dear students? Because here also no friction exists, guys. Only one normal reaction exists. Now observe carefully, sir. How can I able to solve this one, guys? Very simple. First, take the FBD of this point of concurrence I have taken. This is the P. This is the R1. Observe carefully, sir. This is the R2, guys. How much angle it is making with respect to vertical, guys? Alpha plus theta, sir. Alpha plus theta. Observe carefully, sir. This one compared to Lamis theorem, easiest one is taking left force equal to right force, or taking sigma fx equal to 0. Why? Because you can get the Lamis theorem. Because already these two are perpendicular, na? I want only R2. How can I take it, guys? First one, P equal to how much, guys? Left force must be equal to right force. P equal to R2 sin or R2 cos, guys. R2 cos will be vertical. R2 sin, R2 sin of alpha plus theta. P equal to how much, guys? R2 sin of alpha plus theta, guys. Now coming to second one. Second one, R without thinking I can able to say, guys, upward force equal downward force. Here itself you can say. Upward force is how much, guys? R2 cos or sin, R2 cos. Cos of alpha plus theta. Downward force how much, guys? Q. This is the assume, guys. Observe carefully, sir. This is the A. This is the B. Take it, guys. Take it A by B. If you take it A by B, I will get P by Q equal to how much I am going to get? R2 getting cancelled. Sin of alpha plus theta means I am going to get tan of alpha plus theta. Now substitute, guys. Tan of alpha 30. Theta how much, guys? 11.3. So approximately how much, guys? Anyone? P equal to 30 plus 11.3. How much is coming, sir? Yes, 0.87, guys. Very good. P equal to 0.87 Q. Approximate going to get 0.87 Q means the right answer here is the approximate answer is 0.9 itself. But I'm asking the question, guys, is it a good wedge? Is it a good wedge? What is the purpose of the wedge, guys? I have to apply very less force to lift the load, but here to lift, assume, guys, to lift 100 newtons load, to lift 100 newtons load, how much I have to apply, guys? Approximately 90 newtons or 87 newtons load I have to apply. Is it a good or bad, guys? Think about it. To lift 100 newtons load, I have to apply 87 newtons, guys. Is it good or bad? Think about it. Is it good or bad? Let's give the answer, guys. Think about it. Definitely bad wedge, amma. Very good, guys. Very good, very good. Petchapan. Very good, guys. Is a bad wedge. So how can you minimize this one, amma? Simple logic, sir. Always you got it, guys. P equal to Q into tan of alpha plus theta. So my alpha plus theta should be as small as possible. To get it, alpha plus theta should be as small as possible, guys. So make, listen carefully, sir. Make alpha equal to 5 degrees instead of 30. So very bad wedge, 30-degree wedge angle. Very, very inclined, guys. It requires a lot of effort, definitely, sir. Make it alpha equal to 5 degrees and mu equal to 0.1. Instead of 0.2, make it mu equal to 0.1. Theta equal to how much, guys, here? When mu equal to 0.1, theta equal to how much, guys? Can anyone help me, guys? Please tell me, my dear students. Theta equal to how much, everyone? Theta equal to how much, guys? Mu equal to 0.1. Theta equal to how much, everyone? 5.7. Excellent, sir. Theta equal to 5.7, guys. Theta equal to 5.7. So when theta equal to 5.7, please tell me, guys. So P equal to Q into tan of 10.7. What is the tan of 10.7, guys? Anyone give me this value? Tan of 10.7 means how much this value, guys? Everyone. Tan of 10.7 means how much is this value, guys? So how much percentage? How much is value, guys? Approximately I can say 0.2, guys. I can say P equal, I can say, assume my dear students, 0.2 or 1.8, whatever it may be, guys. 0.2 times of Q. Here 0.9 times of Q. Here 0.2 times of Q means for lifting 100, earlier, guys, for lifting 100 you have to apply 90, but here for lifting 100 you have to apply just 20, sir. Which one is best, guys? Which one is best, my dear students? Yes, this is the best. So to make the wedge more economical, to make the wedge more performance, you guys, then my alpha should be reduced, theta should be reduced, guys. Because recently this is what I experienced in my life also, guys. Like in my house, guys, we are having so many unused, like I used to purchase here knives. And after every 2 to 3 months, you might be knowing, guys, the knives lost the sharpness. Then we don't go to the market and go for the like a sharpening tool and all, guys. Then generally we purchase a new knife, amma. Like this happened from past couple of years, same thing is happening. Every 3-4 months we are changing the knife, guys, instead of sharpening the knife. Then it become almost more than 10 knives are there in my house. Then this is not the way to sustainable, guys. Then I brought from the Amazon, guys, I brought one knife sharpening tool, amma. Then I keenly observed what is the difference before sharpening and after sharpening, guys. Before sharpening, if I'm trying to cut a cucumber or carrot, I'm putting lot of effort. But after sharpening, guys, I literally can able to feel that it is cutting very easily, sir. But during sharpening, what you are doing, sir? During sharpening, what you are doing, guys, sir? If you take the cross-section view of this one, guys, listen carefully, sir. During sharpening, definitely, sir, earlier the surface become rough, you make it smooth, amma. You make it smooth. During sharpening of a knife, you reduce the mu value. You reduce the mu value means theta will be reduced, guys. Ultimate aim is to alpha plus theta should be reduced to cut the objects very easily, sir. But during sharpening, what you do? You try to reduce the friction. You try to smoothen the surface, guys. My theta will be reduced. But at the same time, we have seen, guys, during sharpening, indirectly you are reducing alpha also. Because earlier this is alpha, sir. During sharpening, you cut this one, na? Definitely, guys, you are reducing alpha also. So at the time of sharpening, because when you try to sharpen the sides, guys, my alpha will be drastically reduced. So my alpha also you are reducing, sir. Theta also you are reducing, sir. That's why you can feel the difference before sharpening and after sharpening, sir. But you can't keep on sharpening, sir. After some time, what happens, guys? This loses the strength. Because you keep on reducing, this loses the strength, it becomes useless, guys. That's why if you go to any restaurant and all, guys, you might have seen the guy who cuts the onions every time. You might have seen that there is a cut portion will be there at this location, guys. What happened? He keep on sharpen. This pot might have broken. It came to some other mouth, guys. Are you getting it, sir, everyone? Clear? So this is a really dangerous, really dangerous, guys. After a few uses, you have to throw out of that knife, get the new knife, guys. Okay? I hope you understood this topic very, very well, guys. And next time, if you get the question from this topic, you should not leave it. I hope you can able to solve the questions very easily, sir. Okay? Now, clear everyone, guys? With this, I'm stopping this session. Wish you all the best, guys. Wish you all the best, Amma. Thank you so much, guys. Thank you, Ashwin. Thank you. Thank you. Thank you, guys. Thank you so much.